Well, we're back with the conversion of the BC-459A to all solid state. And in the last video, we did demonstrate how it put out 40 watts. Got some updates here. As you can see, I've installed a couple of these little cooling fans, 30 centimeters by 30 centimeters, and they're parallel together. And I decided to use a thermostatic device to turn them on and off as the temperature got pretty hot on the heat sink. So the radio is on. That's just slightly warm. It will only come on when I key the transmitter. So here we go. So let's key it up. And we also made an improvement and got 5 more watts out of it for a total of 45 watts. I would like to show you now how effective this low-pass filter is. It's supposed to be good for 10 watts. I changed all the capacitors in it so that it could handle the 45 watts. I increased the voltage rating on those. I believe they're 200 volts. So let's key the transmitter up. Now we got the scope on the input of the low-pass filter, which is the output of the RF amplifier. Let's key it up. Take a look on the scope. So now you can see the fundamental frequency. You can see the first harmonic, 14 megahertz. You can see the second harmonic, 21 megahertz. And a little tiny blip down there is 28 megahertz harmonic. Yeah, fans just came on. As you can probably hear them now. So how effective is the filter? Well, first of all, let's change the triggering so you can see how not so nice looking that waveform looks. It's definitely got harmonics in it, so let's go back. Alright, let's go over to the output, take the scope and put it on the output of the low-pass filter. Let's take a look, see what that did. Key it up. Alright, it cleaned it up pretty nicely. Not only did it clean it up nicely, let's take a look and see what the waveform looks like. Ah, very nice. I like that. So, very important to have that low-pass filter installed on these type of RF amplifiers. And again, we get to 45 watts. And I'll show you how I increased the. I increased it without increasing the DC voltage. We're running 13.6 volts to the amplifier. So there's the fans there running. Okay, so let's turn it over and take a look. Shut it off. Don't need to hear the fans running. So what I did to increase the voltage is I installed this pot, this rheostat pot right here. And what that's doing is controlling the buffer amplifier down here. It's controlling the current going through that. And it raises and lowers the power that's outputting to the input of the RF amplifier. I also changed out one of these little coupling capacitors to an air variable just for experimentation. It was a small one, like PCB board mounted type. So at this point, the project is complete. Let's take a look at the circuit diagram. Okay, there's the circuit diagram of the Hartley oscillator right here. You can tell it's a Hartley oscillator because there's that tap on just a few turns up from the cold side of this plate inductor. Oh, by the way, in yellow are the air variable capacitors that are in this can right here. And this one is the tuning capacitor from the front dial, which is below this can right here. Inside there, I forgot to highlight these with yellow, is the inductor for the tuning capacitor in here. So we got two cast-coded transistors, MPF 102s, with a Hartley oscillator, and then it's capacitive coupled through this air variable to the buffer amplifier. And I added this pot right here to raise and lower the power output that comes through the transistor to the RF amplifier input. Of course, here's your frequency counter output. It's very simple. The key jack has a 0.1 or a 1K resistor across it to ground, so it helps to eliminate some of the chirp, the startup chirp. There's a little current flowing already. And then we got kind of a little bypass capacitor right here. After it leaves this buffer amplifier, it goes to the input of the RF amplifier right here. So it travels through the RF amplifier through this pad to the first amplifier, out these toroidal transformers, into this next amplifier, out the toroidal transformer output here, to the push-pull circuits of the IR50 transistors. They're coupled to this toroidal coil and then outputted to the filter, the low-pass filter. So, not much to it, that's it. So with that, this will be the last video, and we'll move on to some other project. If you like the video, please give us a thumbs up and subscribe. Appreciate it. Thank you now.